So we were discussing interior of the earth, right? Now, so variation in temperature with the depth. This was the topic. We have discussed about what are the layerings of Earth's interior, composition of Earth's interior that consists of Sial, Sima, and knife. Then next is there are certain boundaries. These boundaries are we have the Mohoric boundary. This is between crust and mantle. Then Rapiti boundary. Rapiti is between upper mantle and lower mantle, or asthenosphere and lower mantle. Then we have Lehman, which is between outer core and inner core. State of matter, that is how is the material of the earth differing in the state. Some of the areas are in liquid state, some are in solid, some are in semi-solid. Now combining all this, we have also understood that the energy transfer from the interior of the earth towards the surface is a combination of the conduction and convection. So the outermost layer of the earth, that is lithosphere, is influenced by the thermal convections that originate in asthenosphere. So the lithosphere, which is 100 kilometer thick, consists of the upper layer that is known as crust. Crust is a part of the lithosphere. Lithosphere is not continuous, rather it is fragmented, it is divided, and each segment of the lithosphere is referred as plate. And these plates are in continuous movement, or they are interacting with each other. The interaction of the plate or movement of the plate is because of the thermal convections again operating in the asthenosphere. So this interaction is referred as tectonics, right? Then we were discussing about temperature, density, and pressure. Density goes on increasing with depth. Density is the function of two things. It is the function of material, the state of material. So wherever there is a solid state, solid material inside the earth, the density will be higher. And even if it is a liquid state, but it may be compressed. It may be compressed by the pressure. So pressure also has an influence on density in interior of the earth. So as we move from the surface to the center of the earth, the density goes on increasing. But is it increasing with the uniform rate? No, the density, increase in density again is not uniform. Pressure inside the earth is nothing but the weight exerted by the overlying material. So as we go down, as we go towards the center of the earth, the pressure is increasing, and we find that the highest pressure is experienced by the inner core. So pressure is one of the factors that helps in retaining the solid state of inner core in spite of the high temperatures. Okay. Then we were discussing about the temperatures in interior of the earth. So I think I gave you the graphical representation of the temperatures. So here the temperature in the initial stage increases with the normal rate. Normal rate of increase in temperature in the crust is 1 degree per 30 meters. And after this lithosphere, there is a sudden spike in temperature. Then it slows down in what? Lower mantle, and then becomes constant throughout the outer core and inner core. Now, the temperature is constant. Now, you should understand this. Why is temperature constant in outer core and inner core? This is because core is the source of heat, the radioactivity, and there is continuous transfer and exchange of heat between the outer core and inner core. This helps in maintaining the temperature constant. Now, why there is a slow increase in temperature in the lower mantle? This is because the conduction in this area is slow. What slows down the conduction? It is the presence of silica. So slow conduction of heat in lower mantle is going to reduce the increase in temperature or rate of increase in temperature. Then in case of asthenosphere, there is sudden increase in temperature within a short depth or short distance. Now this increase in temperature in the asthenosphere is because of concentration of the radioactive elements. Okay, so here radioactivity or radioactive decay that produces the heat is going to increase the temperature, and this is melting the material or convert the asthenosphere into the semi-solid state. Okay. Radioactivity, presence of, so you have written this part. So radioactivity, presence of radioactive elements. Now what about outer core and inner core? The outer core is liquid and inner core is solid. Now what is making a difference between these two is the melting point of outer core and inner core. If I assume that the temperature to be same, like 6000 degrees, if it is liquid and 6000, means melting point here is less than 6000. Solid with 6000 means melting point is greater than 6000. Now here the state of matter in outer core and inner core can be differentiated by the difference in melting points. Now what causes this melting point of inner core to be higher is the compression that is exerted on the inner core from all the direction, or it is the pressure that increases the melting point of the inner core, right? So this was the non-uniform increase in temperatures. Okay, so two important things here. One is how is asthenosphere formed, and how is the difference between the state of outer core and inner core created. Fine.
Why radioactive elements are more formed in matter?
Pardon?
Why?
No, all this radioactivity got settled down. This was the part of movement of the initial material in the blob, right? So the entire earth was radioactive when it was formed. So what happened to this material? Some of this material was taken down. Whatever material was left here, it got decayed, right? So if you compare, now here your answer will be, if you compare the earth 4 billion years before present and the present earth, is the size of the core same? What will be here? Core will be this much, right? Here the core is this much, right? So the core is shrinking. Core is shrinking as the earth is giving away the heat. The size of the core goes on decreasing. This is the part of radioactive decay. Now, so we have discussed here. Yes. No, see, when there was a blob, what has happened to the high density material? It has moved down. But it is not that entire high density material has been taken. So there are some material which is left here also, right? So if I say iron and nickel is taken towards the core, but some part of the crust still maintains what? Iron and nickel. So there is iron ore found in the crust. Similarly, so this movement or this downward movement was not uniform at all the places. Okay. Now next is, note down. So we have discussed about endogenetic forces, origin and interior of the earth. Next to write the classification of the endogenetic forces. Classification of the endogenetic force. What are radioactive elements of the core? Same thing as thorium, uranium, radium, radon. Okay, so radium decay will be radon. It produces the gas. How does the center of the earth stay 6000 degrees same after? Now, this is not going to stay for a long time, in the sense that some time ahead, this energy is going to get reduced, right? So the Earth's geomagnetism is a function of this heat. That is why the magnetic property of the Earth is also changing as the material of the core is changing. We will discuss that. Now, classification of the endogenetic forces. Endogenetic force are classified into two. This is known as dystrophic forces and catastrophic force. Dystrophic force and catastrophic force, or dystrophism and catastrophism. What is meaning of dystrophism? Where the outcome of these forces are recorded very slow. Like for example, movement of the plate is dystrophism, mountain building is dystrophism. So these forces are having a slow operation. Their outcomes are very slow. This will be known as dystrophic. So tectonic is a dystrophism. Plate tectonic is dystrophic. Continental drift is dystrophic. Mountain building is dystrophic. Any upliftment of the land is also dystrophic. Then what is catastrophic? Catastrophe means those forces which are going to have the sudden expression. They are creating something all of a sudden on the surface of the earth. This will be known as catastrophic events or catastrophic forces. Example of catastrophic outcome is earthquakes or volcanic eruption. Eruption I am talking about, not volcanism. When the magma erupt, this event is sudden, okay, within a very short time. So this type of forces are considered as catastrophic. So majority of the Earth's surface features are what? Whatever we are seeing on the surface of the Earth, majority of them are created by dystrophism. Majority of the Earth's surface, no doubt, majority of the Earth's surface features are the outcome of dystrophism. Majority of the Earth's surface features are the outcome of dystrophism. Right. Assertion reason important. Now, we'll see separately the catastrophic forces as the topics. Now, let us focus on dystrophism. So, dystrophic forces can be further classified into two, depending on their orientation, how they operate. What is the orientation from the interior of the earth? So this will be a vertical force in the sense perpendicular to the surface, and there are forces that operate horizontally. Horizontal forces. Horizontal force means which are parallel to the surface. Now this is the surface of the earth. If the force is operating like this is vertical force, right? And if the force is operating in this way, this will be horizontal. Now, what is going to determine this vertical and horizontal force? It is the orientation of convections that are present below the lithosphere. So this is the lithosphere, and let us say this is the convection in this way. This is the thermal convection. At this point, which force is experienced? Vertical force. Here, which force is experienced? Horizontal forces. So it is the orientation of thermal convection that is going to decide the vertical and horizontal. So vertical forces are also known as epirogenetic force. Terms are important. Epirogenetic. Vertical force are epirogenetic, while horizontal forces are referred as orogenetic force. Epirogenetic, E-P-E-I RO. Epirogenesis means vertical, and horizontal forces are orogenetic force. Horizontal are orogenetic force. Now, so if we consider vertical, vertical has two possibilities. The force that can operate upward, or the force that can operate towards the center of the earth, interior of the earth. So there are two forces in epirogenesis. This is upward force and then downward forces, upward and downward force. Understand the concept here. Example part you can read from the material and your NCERT. Conceptual part is important. Now upward, so these forces, suppose this is the crust or lithosphere and the force is acting like this. So what it will do? It will uplift this part of the crust. There is upliftment. Okay, upliftment. So upward force will cause uplift of the surface. It is going to cause uplift, and this is going to appear like a hill or a mountain. This is a mountain. Let us say now this type of mountains are known as block mountains. So what is the outcome of upward force? It is the formation of the block mountains. Like you find the block mountain of France, Vosges of France, or it is the Black Forest of Germany. These are some examples of the uplifted block mountain, where the surface is, that part is getting raised, is known as a block mountain, vertical. In case of India, some part of the Western Ghat also represents the uplifted block, Western Ghat. Now, you see here, this is the surface of the earth, and here it is getting uplifted. So here is a block. And one more vertical force of same intensity or similar intensity operates nearby. Here also there is a uplifted block. So you got two block mountains, and in between them there is a valley. A valley is formed. So this type of uplifted blocks, or any uplifted block, will be known as horst, Horst. So the term used for the block mountain or uplifted block is horst, Horst. And the valley between the uplifted block, this is known as a graben. So we have a horst graben structure. Valley between the uplifted block, the depression that is there between the two blocks, is known as a graben. Now take example, in case of India, some of the parts of Vindhyas are uplifted block, and even segments of Satpuras are uplifted, and in between them there is a valley through which the river flows towards the west, that is Narmada flowing towards the west. So these Vindhyas and Satpuras are the example of horst, and the Narmada valley is an example of graben. Okay, so you can mention their example, Vindhyas and Satpuras. These are parts of Vindhyas and Satpuras are the blocks.
Is any possibility that gravens are not formed?
You have a single uplifted structure, So there is no valley for this. If there are, now between the two mountains there will be some gap, right? If there are elevated structure, there will be some gap between the two mountains. If this is a single unit, then it will be a plateau if such large area is there. Now, the second one is downward force. Downward forces. Now, force operating from the surface towards the interior. This is the downward force. What is the outcome of this? This is going to cause a depression on the surface. So this will move down. So there is formation of the depression on the surface, and this depression sometimes may be filled by water. So these are the water bodies or lakes that are found on the surface of the earth due to the downward force. The downward forces create the depressions, and these depressions are like unevenness where there is accumulation of water. So formation of water bodies or lakes. So all the major water bodies, if you see, these are the part of such depressions. Now, second is orogenetic forces. This is important for objective question. Questions from this are more possible. Is whole range of Vindhyas and Satpuras block mountain or only the part? Whatever I am telling, please concentrate on that. What I told you, only a part of Vindhyas and Satpuras are the raised block, because Vindhyas are made up of both folded and block structure. Then how downward forces are created in interior of the earth? Yes? How is downward force created in interior? This is because of descending limb of what? Thermal convection. First, let the topic be over, then you can ask the doubt. In between, don't disturb or don't break the link. Orogenetic forces are horizontal force. Okay, horizontal means they are parallel to the surface, right? So they cause sliding of the crust, horizontal movement of the crust in this way. The orogenetic forces can have two orientations. So the forces can operate towards a point, the two forces operating towards a point, or the two forces can operate away from a point. In tectonics, this will be known as convergence and divergence. Okay, but here, because this is not a tectonic theory, we will use a general term. So this will be referred as a compressive force. Okay, compressive force. Force acting towards a point is a compressive force, and force acting away from a point, this will be known as a tensional forces. Tensional force, or this will be simply referred as expansive forces. Tensional or expansive force. Now, let us see a tensional force. So suppose this is a crustal block, this is the crust, and the force is acting at this point away from each other. Means what? This is the two thermal convections which are oriented in a opposite direction. The meaning is this. So what is the result of this tensional force? It will develop a crack on the surface, right? This will be known as a fault Fault is a fracturing of the crust. Fracturing or crack on the crust is referred as fault. Process is known as faulting. Faulting. So if the crust is broken, what will happen to the strength of the crust? Increase or decrease? Decrease. This will become weak. The fault zones are weak zones on the surface of the earth, and these faults can allow the energy from the interior of the earth to get directly reflected on the surface. So if energy can be expressed on the surface, these areas will be known for earthquakes. Fault zones are the weak zones, and they are characterized by earthquakes. There will be earthquakes in this region. Wherever there is faulting, earthquakes will be there. Okay? This will occur together, fault and earthquake. Now, if this fault is expanding, right, and there is a narrow structure created, narrow V-shaped deep structure is created, this will be now known as rift. The fault expands and widens to create a narrow deep incision, deep structure. This will be known as rift. See, example of the fault is in case of India, you can see there is a fault line which passes through Gujarat. This is known as the Great Indian Fault or Indian Fault Line, which is passing through Gujarat. And the activation of this fault will cause earthquake in the state of Gujarat and Madhya Pradesh. Like Bhuj earthquake of 2001 was because of the activation of this fault line. So in fault, you can write the central fault of India, central fault of India passing through Gujarat. Central fault line of India passing through Gujarat is the reason for earthquakes. Reason for earthquakes in Gujarat. Example, Bhuj earthquake of 2001. Bhuj earthquake of 2001 was due to activation of this fault line. Activation of this fault line. Fine. Now, so fault gets converted into rift. Example of the rift is this here. This is known as East African rift. So here it first developed as a fault and then it started expanding, and today we find there is a wide rift created inside Africa. This is known as East African rift. East African rift. Now, if there is accumulation of water in this is now known as the lakes. But which type of lake? Rift lakes. Okay, these are the rift lake, and this region of Africa is characterized by multiple rift lakes. Like you have the Lake Albert, then Lake Turkana, Lake Malawi, Lake Tangaike. These are some of the lakes of African rift. Albert, 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 Turkana, Turkana, Malawi, 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 and Tangaike, Tangaike. Now here you have the countries. Now later on after the class, look at the map of Africa physical. You will find this and note down all the other lakes also which are present as a part of rift here. So you'll have the countries like Kenya, Uganda, Tanzania, right? And most of the borders of the countries lies in these lakes. So here the concept is first formation of a fault, then modified to rift, and this rift will expand and will get converted into a large water body, and this will be a sea, which is now a separation of two land masses. Okay, so here the two continents or two land masses get separated by the formation of the sea. If the rift further expands, if the rift is further expanding, there will be separation of the land mass. Right. Example for this is again you can see the region of this part is the formation of formation of Red Sea, which separated Arabian landmass from African landmass. Okay, so the formation of Red Sea is an example of separation of the land masses. Now here also we can expect this thing, like what is the future of Africa? If after few billion years you'll find that this rift will expand and there will be a birth of what? A new continent. A new continent will come into existence, right? So Red Sea is an example of this. Now, so this is a crustal block, and here is a fault line. Assume this is a fault F, and there are two blocks A and B. If this block A remains as it is and the block B is pushed down, it slips down, it moves down. So here along the fault line, there is a movement of the block. One block is shifted below the other, it is slipping down. This type of faults will be known as, this is known as the normal fault. This is referred as a normal fault. What happens in the normal fault? The one block slips down below the other. Block A is maintaining its level, B has been shifted down. But there will be a case where you have a block A, and in this case a block B is pushed upward. Block B is pushed up along the fault line. A is at the same level, it is maintaining its level, and B, the block B is pushed upward along the fault. When the block is raised upward, this type of faults will be known as reverse fault. Reverse fault. So there is normal fault. Normal fault mein kya hoga? The block is pushed down, it slips down. This will be known as a normal fault. When the block is raised up, this will be known as a reverse fault. How it is created, that we'll see ahead. Just look at the identity of the fault. So normal fault, downward movement, and reverse fault, upward movement. Okay. Now, assume that this is a crustal block like this. This is block A, and here is this is block B. This is A and B. Now, in this case, there is no rise or there is no downward movement, no upward or downward. Rather, it is what? A parallel movement like this. So, there is a parallel movement in this way, right? So, here, what has happened? This block has moved in this direction and A has moved in backward direction. So, there is a parallel movement of the two crustal blocks, parallel movement of the two crustal blocks. This type of fault is referred as simply a slip faulting or strike slip fault, or this is also known as a transform fault. Transform fault. Transform, transverse, strike slip fault, or slip fault, or transfer fault. Transform fault. What is that? When the two blocks are moving parallel to each other. Okay. So there are three types of fault: normal, reverse, and parallel, or you say the slip faulting. How we identify this type of faults? What will be the criteria to identify that this is a slip faulting or normal fault, or this is the reverse fault? On what basis we identify this? Yes, movement है, लेकिन movement तो आपको daily नहीं दिखेगा ना, right? This is a slow process, so you will identify this based on what? The mismatch in layering of rocks. Okay, mismatch in the layering of the rock. So layering of rock, this is an important criteria to identify the type of fault. Arrangement of the rock will be an important criteria to arrangement or layering of the rock is a criteria to identify the type of faults. Right. Now, this is the rather the most important method for. There will be other also, just a drainage system, change in the river course. Just a river is flowing on the surface. Okay, this is a continuous block like this, and the river flows in this way. Agar ye slip fault hoga, or if it is a normal fault, what will happen to this block? This will move down. So ab river kya karega? River will fall from a greater height. So what it will create at the edge? A waterfall will be created, right? Or if it is a slip fault, what will happen to? So river is flowing in this direction. These are the two blocks, and it slips. So the change in course of the river can be seen, shifting of course of the river. So river is also a criteria, but this may not be same at all the places, because there may be a climate change, there may be a changes in the sources of the river. So the most important criteria, if you are getting an objective question, that will be the arrangement of the rocks. Okay. Now, suppose there are, I'm taking 3 blocks now, or you take first 2 blocks and understand the formation. So this is a fault line F. This is block A and B. And now these 2 blocks, a crack is developed, and after development of the crack, a tensional force, compressive force is acting on these 2 blocks. Okay? The 2 blocks are moving towards each other. What is the resultant outcome? Normal fault or reverse fault? If 2 are moving towards each other, what will happen? In this case, this block B will be shifted upward. Okay, this will shift up, and there will be formation of reverse fault. So what I can write? Reverse fault is equal to a fault plus which force? Compressive force. Okay, a fault on which a compressive force is acting will convert it into a reverse fault. there is a fault line. First, ये crack develop हुआ है. This can be because of initial forces. Fine. This is a block A and block B. This is the inclination of the fault. Fine. Now, block A and B are moving towards each other. So what will happen? Along the inclination, the block B will be pushed up. Okay. कैसे जाएगा? Now, you see the inclination here, right? If the two forces, you see these are the two blocks and I am exerting, ये inclination है, तो ये ऐसे slip होगा ना ऊपर की तरफ, right? हाँ? कैसे नहीं होगा? If it is like this, then you have A will move up, right? This depends on how it is cracked, how the fracture zone is, right? So if the inclination of the fault is like this, A will move up. If it is in this way, B will move up, right? So here it is it becoming more technical? Huh? Nahin? Are you getting this? Or it is beyond your capability to understand? Huh? So I'll teach what you can understand. So reverse fault is the fault plus compression. Fault plus compressive force. A compressive force acting on the fault will result in the reverse fault. Now, if it is a crustal block like this is A and B, and there is a tensional force acting on it. Tensional force. What will happen? Now, in this case, the block B will move down. Okay, if you have inclination of fault in this way, A will move down. So here there is a downward movement. So here we'll write normal fault is equal to fault plus which force? Tensional force. Normal fault is equal to a fault line on which a tensional force is operating, right? The movement of the block, as he was saying, depends on inclination of the fault, how the fault is arranged. This is going to decide which block is going to move. Now, suppose I am considering 3 crustal blocks, A, B, and C. These are 3 blocks and there are 2 faults, F1 and F2. Now, in this case, if a compressive force is acting from A and B, means A and B are moving towards each other, what will happen to block C? Block C kya hoga? It is going to move up. Right. So this C will rise here. C is going to rise along the fault. So what is this 2 type of fault here? Normal fault or reverse fault? F1 and F2 will be reverse. Okay, this will be a reverse fault. So you will find this as, this is block A and this one is block B moving towards each other, and this part of the crust has been uplifted. This is an uplifted block along the fault line. So F1 and F2 are reverse fault and there is an uplifted block. Now this is rising. This crustal part is rising. This is the formation of, yes, this will be the formation of what? Block mountain. In this way, the block mountains, any block mountain will be characterized by how we differentiate a block mountain from other type of mountain. Every block mountain will be characterized by faults. Okay, fault line will be the characteristic of the block mountain, uplifted blocks. Okay, so formation of the block mountain, uplifted blocks by two fault lines and compressive force. Now, instead of this, if it is two blocks A and B and this is C, and there is a tensional force acting on A and B. Yes, tensional force acting on A and B. What will be these two faults? F1 and F2 will be normal. Okay, this is going to be normal. So what will happen to the block C? The block C will subside. Block C will move down. So here it is in this way. There is a downward movement of block C. So how is this block A and B appearing now? A and B appear as a raised block and C is appearing as a valley or a depression. This is which type of structure? Horst and Graben. So A and B appears as a block and C is a depression, downward movement, which is appearing as a Graben. So this will be the formation of the Horst and Graben structure. Right. So here we are considering, now is this surface of the crust is flat like this? No, this is uneven. This is just a diagrammatic representation. So downward movement. So whenever tensional force acts and there are two faults, the two faults on both the side of the block will act as a normal fault, will result in subsidence. Two normal fault will result in subsidence. Two reverse fault will result in upliftment. Okay, two reverse fault is going to result in upliftment. So in this way, there is a formation of a block mountain. Now, so when we are considering mountains, mountains are classified into three types: fold mountains, then there is a block mountains, and also the mountains created by volcanic eruption, the magma coming out, getting deposited on the surface and create a conical structure, that will be known as a volcanic mountain. Like volcanic mountain created under the ocean, and this rises up to the sea level. The tip of such mountains sometimes rise above the sea level, and that is visible as what? Islands. So these are volcanic mountains that are emerging from the ocean floor. Or there are some volcanic mountains that are directly visible on the surface, but they are generally a volcanic peak instead of a range. So fold mountains are created by folding. Folding means this is by compressive force. Block mountains are created by what? Faulting. Okay, blocks are associated with fault, and volcanic mountains by magma. Now, the mountain building on the surface of the earth has been in different phases. So if you study the mountains of the world, we can classify the mountains into 4 periods of their formation, like the mountains that were created during the Precambrian period. These are the oldest mountains, means those created 2.5 billion year before present. Okay, these are the Precambrian mountains. Then there are mountains. The second phase was Caledonian mountains, or this is known as late Precambrian. Okay, late Precambrian or Caledonian. Then it is Hercynian. Hercynian mountains. Now, Hercynian mountains, these are around, I'll give the mid period like 300 million years, 300 to 500 million years before present. These are something like 1000 million years to 1500 million years before present. These are 2.5 billion years. Okay, so this is the chronology. And the last one is known as Alpine mountain system. Alpine mountains are the latest one. Alpines are latest. Now, so which are most elevated mountains now? If you see the present structure, the most elevated will be the most recent. Whatever formed in Precambrian, are they existing as it is today? No, they have been brought down, or most of them have been converted into very low-lying shields. Example for this is like Canadian shield, Canadian shield, or the Laurentian mountains, Laurentian shield of North America. Canadian shield, this is the northern part of Canada which has been brought down. And Laurentian again, that is northeast part of Canada, northeastern region of Canada. This is known as Laurentian, that is Gulf of St. Lawrence. Alpine, what will be there in Alpine? All the present mountains, that is Himalayas, Alps, Rockies, Andes, all the mountains that emerge from the Pamir Knot, that is all Hindu Kush and Zagros, Elbrus, this, the Pamir mountain ranges, these are Alpine. Then what is there in Caledonian? This is late Precambrian. Here is Aravallis. Aravallis is the Caledonian. Sometimes it is also known as Precambrian because we don't have that exact differentiation of age. But as far as periods are concerned, we can put it in the Caledonian period. Aravallis, late Cambrian or Caledonian. Here also is the mountains of northern Europe, mountains of northern Europe like Cantabrians, are Caledonian. Here you will find Hercynian mountains. These are the Appalachian mountains, then Altai, Urals, Altai and Urals, they are considered as the Hercynian mountain. Now you should understand the periods here. So these are the 4 phases of mountain building that Earth has experienced, and every phase is characterized by some feature, and over a period of time their heights have been reduced. These mountains today, which are belonging to Alpine phase, or this is also known as the tertiary period of mountain building. The recent phase of mountain building is also referred as the tertiary phase. So all the mountains of Himalayas, Alps, Rockies, Andes belong to tertiary. These are the most recent mountain chains of the world, and they are most elevated. What has happened to these Appalachian, Altai, Urals? They have been slightly degraded. This one have been furthermore degraded. These are now almost lying very close to the sea level. Okay, so they have been most degraded mountains, that is Precambrian, right? So in this way we understand the mountains are the second order landforms, they are classified into 3 based on their origin and 4 based on their period of formations. Okay. So sometimes you may get these terms in the question, so it should be useful. Now come back to the orogenetic force. So we have discussed about the tensional forces. What is the outcome of tensional force? Fault, rift, and separation of the landmass. We will apply this in continental drift theory later on. Faults are of 3 types. Then what are these? Normal fault, reverse fault, slip fault. And faults determine the upliftment or subsidence of the land, and that is known as horst and graben. So common feature related to the horst or common feature related to the fault is horst and graben. Fine. Now we will look at the forces that are operating towards a point. Force that are operating towards the point. This is known as horizontal, but it is compressive force. So it is coming under the category of orogenetic. Now, so this is the crust which is experiencing a compressive force. This will be a convergent boundary. If you consider a plate, it will be a convergence of 2 plates colliding with each other. But we'll take up a crust for this topic. So crust with a compressive force, what is the resultant of this? The surface of the crust will experience a bending, and this structure will be known as fold. If it becomes too elevated, this will be known as a fold mountain. Okay. So bending of the crust, bending of the layer of the rock, formation of a fold. And if it is more elevated, this will be referred as a fold mountain. Folding is a process, right? Now, if you name these 2 forces A and B, and A is equal to B, A is equal to B means intensity of compression from both the side is equal. So how is the structure of the fold? The structure of the fold will be also equal from both the side. This is the axis of the fold. This axis is vertical, perpendicular to the surface, can divide the fold into 2 equal halves. This type of folding will be known as what? Symmetrical fold. If the intensity of the 2 forces, intensity of the compressive force is same or equal, intensity of compressive force is equal, it will result in the symmetrical fold. What is symmetrical fold? The axis of the fold can divide it into 2 equal halves. This type of folds are known as symmetrical. Now, because the crust may not be having a uniformity of the rocks. So if this is a force A and force B, and let us say A is greater than B. Now we are saying unequal forces. The intensity of compression is not same from both the sides. In this case, the folding is, or the fold becomes inclined. How is the axis of the fold? The axis of the fold is also making some angle other than 90 with the surface. It is inclined to the surface, inclined to the surface. This limb of the fold is now inclined and cannot be divided into 2 equal halves, right? This cannot be divided, and this becomes asymmetrical folding. This is asymmetrical. When intensity of compression is not same, intensity of compression is unequal, this is going to be asymmetrical fold. Now, suppose the surface rock, this layer of the rock and the rocks below. So we have two layers of the rock on the surface. The upper layer is relatively soft or less resistant rock, and this layer is a hard rock. Means there is a difference in rocks of the crust. And this crust is acted upon by two forces, A and B, and A is greater than B. Now, if A and B are equal, then both will be compressed with equal intensity and there is a symmetrical fold. लेकिन यहाँ पर A is greater than B and there is a difference of rock. So, in this case, we'll find that the upper layer of the rock experiences bending and it bends. So, which will have a greater resistance to the compressive force. Which rock? Hard rock, lower rock. So it will not undergo much of the bending. This is the hard rock, which is having some resistance to the compressive force. But what happens to the upper rock? It will easily respond to this force and the upper part of this limb will move ahead. Okay, this is pushed ahead. This soft rock will be pushed ahead and there is a limb inclined to the surface. Limb inclined to the surface. It has more inclination compared to the previous one. This type of fold is referred as recumbent fold. So what is recumbent fold? Which is inclined and the axis of such fold is almost what? Parallel to the surface. Recumbent fold, the axis is more inclined and becomes almost parallel to the surface. Yes, able to get this. So when is recumbent fold created? When there is a difference of rock, the upper layer of the crust consists of soft rock or less resistant rocks. Okay? The interior rocks are not going to respond to these forces much. The folding of interior rock is relatively less. Upper rock responds more easily, not only bends, but it is pushed ahead. Okay, pushed ahead and becomes parallel. The axis becomes parallel and there is a gap between limb and the surface. Now, if there is third case, if this is the crust and this entire crust is made up of a less resistant or a soft rock. Now there is no difference of rocks here. The entire region is made up of soft rock. Soft rock means which type of rocks are considered as soft? Sedimentary. Sedimentary are considered as a soft rocks having less resistance. Now there is a compressive force acting on it. If it is equal, there is no much complexity. It will directly create a symmetrical fold. But if you say here it is A and B, A is much greater than B. There is negligible force from one side and there is intense compression from the other side. Now in this case, how is the folding? The entire structure is the rock with less resistance. There is unequal compression from both the direction or unequal compression. There is very high intensity compression operating from one side. In such cases, this surface will get folded and not only get folded, the entire fold now bends and lies on the surface. Okay, so it will bend and lie completely on the surface. Okay, so this type of structure is referred as, this will be known as NAPPES, NAPPES. structure is known as nappes. So condition for nappe is it should be uniformity of the soft rock, low resistant rock, and unequal compressive force and very high intensity compression acting from one direction. Now, what is the difference between? Can you identify a difference between recumbent fold and nappes? Now, structurally, this which is going to appear more elevated, recumbent will appear more elevated. Which is appearing like a shield or a plateau, it will be nappes, which is appearing like shield or plateau, right? Now, other differences. This gap which is present between the limb of the fold and surface is absent in case of nappes. The limb of the fold is completely attached to the surface. So the gap is not there. In case of nappes, you don't find a gap. Right. So these are the types of. So what we have discussed here is the type of fold. So compressive force is resulting in fold. The folding depends on the structure of the fold depends on intensity of compression, first factor. So you get equal compression, symmetrical fold. The type of fold also is dependent on the type of rocks and layering of rocks. Okay, objective question, type of rock and layering of rock. So if unequal compression, it will result in asymmetrical. If there is difference of rock, it will create recumbent. Okay, and if it is unequal compression with imbalanced compression with a soft rock, this is going to create a nappes. Okay. Recumbent you can find, see this is the interiors of Himalayas. Interiors of Himalayas like middle Himalayan ranges have the recumbent fault, and towards the Shivalik you will find these are nappes. Now you will get these features in interiors of Himalayas because Himalaya is a fold mountain. Himalaya is a fold mountain, but the intensity of compression in every part of Himalaya was different. So interiors like middle Himalayas will have recumbent folding, and the lower ranges of Himalayas like Shivalik will have the formation of nappes. Fine. Suppose, now see here, you have been given this is a mountain, and I say here is a block mountain, and this is a fold mountain. Both are appearing same of equal height. How we can differentiate between the block and fold? How we identify that this is a block mountain and this one is a fold mountain? Presence, one is the presence of fault, very good. Or kuch? Yes, very good here. It is the layering of rock. Block mountain में कैसे होगा? There will be a horizontal arrangement of the rocks. In case of fold, you'll find the profile of the rock is with bend. Okay, there is a bending of rock. Okay. So arrangement of the rock again becomes a very important criteria to differentiate between the block mountain and fold mountain. By observing you cannot say, because many places they appear to be same. Like take example of Vindhyas, a part of Vindhya is a block and part of Vindhya is a fold mountain. Okay, so observation you cannot differentiate between the two, but it is only by looking at the arrangement of the rock, layering of rock, bending of the rock, these two forces or two mountains can be differentiated. Right. Now, suppose this is a folded structure or fold mountain which has multiple ranges. So the raised part of the fold is known as anticline. the raised part, the crest is known as anticline, and the depression that is there between the fold, this will be known as syncline. The depressions are referred as syncline. So whenever there is a folded structure, fold mountains, there will be two parts, crest and trough. Jaise it was there in case of block also. In block it was horst and graben. Okay, horst and graben. Here it is anticline and syncline. So syncline is a depression. So if you are asked, syncline is the outcome of which force? Epirogenetic or orogenetic? Huh? This comes under folding. Folding means what? Horizontal. This is orogenetic. Question can be in this way. Synclines are the result of orogenetic forces. Horizontal forces are folding. Now, if you apply this concept to the formation of Himalayas like this, so this was Himalayas and this is the raised part. So Himalayas represent, yes, Himalayas represent anticline, and when Himalayas were created, in front of Himalayas, there was also a corresponding depression between Himalayas and remaining part of India, and this was known as Himalayan geosyncline. So if the depressions are large, we attach a word geo to it. Okay. So normal depressions, normal small area, if they occupy a small area, we can use a word syncline. If they are covering a large area, we will be using a word geosyncline. So this was a Himalayan geosyncline, a depression that was existing in front of Himalayas. So what has happened to these? This was filled by the sediments brought from the Himalayas by the river, and this was converted into, yes, converted into what? Northern plains. Okay, this is how the northern plains were created. Northern plains, that is the Ganga plain and Punjab plain. So northern plains of India were formed by infilling of the geosyncline by the Himalayan river or sediments brought by the Himalayan river. Mentioned there, the northern plains of India were created by northern plains of India were created by the infilling of geosyncline, infilling of the geosyncline by the sediments brought from Himalayas or brought by Himalayan rivers. Okay. So what type of rocks are present in northern plains of India? Depositional hai, so it will be sedimentary rock. And what type of soil is found in northern plains? Depositional soil means what? Alluvial soil. So there is existence of alluvial soil and the sedimentary rocks in the northern plains. So here you should understand this concept is important because again we'll be using it in Indian geography. So what is the difference between so this is block mountain. Block mein will write horst and graben. Here we are writing anticline and syncline. What is the difference here? Difference will be in the layering of rock. Here it is horizontal layering with fault, and here it will be the bending of the rocks. Okay. So this is about the endogenetic force, classification of endogenetic. There will be information part of this topic. You should be reading NCERT to add information to this topic. Conceptual part I have covered here. Factual things to be added from NCERT. Now, next to write exogenetic forces. Exogenetic force. Now, all these important for prelims, not for mains. Exogenetic forces, the forces that operate from outside, having the origin in the atmosphere of the Earth, outside the Earth, are known as exogenetic forces. What is the role of exogenetic force? Suppose this is the landform. If exogenetic force is operating on this landform, it will reduce the height of the landform and finally bring down these landform to the base level. Therefore, the exogenetic forces are also considered as destructive force, or they cause degradation of existing landform, or we can say that they are referred as the leveling forces. Destructive, degradational, or leveling force. So, exogenetic forces operate by two mechanisms. There are two mechanisms of operation of exogenetic force. One is weathering and second is erosion. So there are two processes involved in exogenetic forces or geomorphic process, weathering and erosion. Weathering plus erosion, the combined effect of this is known as denudation. This is denudation. So we use a geographical term, geomorphological term for degradation as denudation. So degradation is synonymous to denudation. So what is denudation? It is nothing but downwesting of the landform, decrease in height of the landform. This is because of two processes, weathering and erosion. So if the landform is degraded, we can write instead of word degradation, denudation. We say denudation of the landform, denudation of the mountain, denudation of the plateau, in this way. Okay. So suppose this is a landform and it is undergoing weathering and erosion or denudation, and in 10 years the height of the landform has been reduced by, assume, 10 meters. Means what is the rate of denudation? 1 meter per year. Okay, this is known as rate of denudation. So if the height of these mountain is 1000 meter, okay, 1000 meter, we can estimate, we can approximate that how long it will take for this mountain to be brought down to base level by study of present rate of denudation. So if it is degraded 1 meter per year, by this rate it will get reduced in next 1000 years. Okay, this will be there. If this is the rate of denudation and this has operated continuously in the past, assume that we are aware about what was the climatic condition of this region in the past, and this has operated continuously for another 1000 years in the past on this landform. So present rate of denudation can help us in reconstructing what? The past of that landform. Means 10,000 years before present, what was the height of landform if you study the present rate of denudation. So this method by which we can reconstruct the history of any landform by studying the present processes operating on that landform is known as denudation chronology. Right? Note down definition. The method of reconstructing method of reconstructing the history of landform method of reconstructing the history of landform by studying the present processes present processes operating on it is known as denudation chronology. Is known as denudation chronology. Underline this. Next point. This is the most important tool in geomorphology to reconstruct the topography of any region. To reconstruct the topography of any region. Right? Able to understand this? It means that how was that region appearing in the past? Now, when I say that Aravallis was 11,000 meter above the sea level when they were created. Now, Aravallis were created 2.5 billion years before present. Now, was human being present near the Aravallis who have recorded something about Aravallis or written about the Aravallis? No. In case of human history, we are reconstructing the human history by some written records, some artifacts, some archaeological sites. They provide us the evidence to reconstruct the history of mankind. But how we reconstruct the history of any landform? We are having this method that is known as denudation chronology. Now, how it is possible? Because there is a principle that every process, every denudational process, every exogenetic process that has operated on the landform has left a distinct imprint on the landform. Now, for example, there was this was a mountain. This was a mountain, and there was a glacier on this mountain. Okay. So what this glacier has done, it has left some sediments on the surface. Then after glacier, a river was operating. A river has left its sediment. After that, wind was operating. Then it has left a sediment. Then there was a water body. It has left a sediment. So any process that has operated on the landform has left its imprint, right? So here, how is the landform? Landform is like a glass you get at a crime scene, which has a fingerprint of many individuals who visited that place. Now, when you are studying or making a forensic study of that glass, you will get a fingerprint of the victim, you will get a fingerprint of the relatives who came there, the fingerprint of friends. Okay, so in this way, when there was an evolution of landform, there were multiple processes that might have operated on the landform, and every process have left its own imprint in the form of rocks, in the form of drainage, in the form of sediments, etc. And these imprints help us to reconstruct the history of that landform, and this method is known as denudation chronology. Are you able to get this? So now this is not very simple, but as far as GS is concerned, this much understanding is sufficient. So there are two processes, weathering and erosion. What is meaning of weathering? It is a disintegration of the rocks, or simply breakdown breakdown of the rocks. When the rocks break, this will be known as weathering. Disintegration or the breakdown of the rock is known as weathering. Erosion means it is transportation of the sediments of the rocks. When you move the sediment from one place to other, when you move the rock from one place to other, this process is known as erosion. So erosion is a translocation. Erosion is a movement. So erosion requires some medium to move the material from one place to other, and this medium is known as what? Agent of erosion. So medium that can carry the material from one place to other, this is known as the agent of erosion. Now, in the previous one, in denudation chronology, the doubt is that the denudation might not be same in different periods of time, right? That is what I am saying here, because when we consider a simple definition of denudation chronology, what we have written, by studying the present process, we can reconstruct the history of that landform. But the present processes and past processes of the landform, are they same? No. That is why we have the second approach. What we are saying, every process that have operated has left a distinct imprint. Okay, so in that way, we are able to cater the complexity of the processes that have operated. So suppose there was a mountain and the continent was moving. A continent came close to the polar region. What was the process on that mountain? Glacial. Then it came to the temperate region. What was the process? Fluvial. Then it came to tropical region. The process was wind process or arid process. So processes went on changing. There is a change in process. That is why rate of denudation, will it be same in all the periods? No. Now we cannot say that if Aravalli is degraded by 1 meter every year, and this will be the rate of denudation in entire past of Aravalli. If you go by this 1 meter per year, 2.5 billion year before present, the height of Aravalli also will be 2.5 billion meters. Now this is not going to happen because the processes were different, the intensity of denudation also was different. Okay. Now this is clear to everyone, denudation. Now weathering is disintegration of the rocks, and erosion is the transportation. Transportation requires a medium. These mediums are referred as agent of erosion. What are important agents of erosion is water, then wind, then it is glacier, and then it can be the sea waves. Water, wind, glacier, and sea waves, these are the major agent of erosion. The most dominant agent of erosion is what? Water. Majority of the erosion on the surface of the earth is by running water, the surface flow. Surface flow means it will be in the form of streams, tributaries, rivers that can transport the rock and the sediment of the rock from one place to other place. Now, weathering is disintegration. Now, disintegration of the rock depends on the factors or the conditions operating on the rock, and this is going to determine the type of weathering. Rock is getting disintegrated, but what causes disintegration may not be same at all the places. Am I correct? So some places it may be a temperature, some places it may be a gravity, some places it may be sliding and slumping. Okay, so there may be a multiple factors that can cause the weathering. So based on this factor, we have the types of weathering. Types of weathering are the physical weathering, physical, then it is a chemical weathering, biological weathering, and anthropogenic weathering, right? Now, look at the last one, anthropogenic, the disintegration of the rock caused by human activities. Now, what are the human activities where we disintegrate the rock or we break the rock? Mining, quarrying, construction, any kind of infrastructure development. These are anthropogenic. What is a biological weathering? Means flora and fauna. Life forms are responsible for the disintegration of the rock. Example for this is the penetration of the roots. When the roots they penetrate down, they engulf the rock, and over a period, because of these roots, the rock get disintegrated, rocks break. This is the example of biological. Or burrowing by the animals. There are some burrowing creatures who go into the rocks or between the rocks and they break the rocks. So this is known as biological. Just read the examples here. Questions are more possible from the first two, physical and chemical weathering. Now, chemical weathering. The rock is getting disintegrated because of a chemical change or a chemical reaction occurring in the rock, right? Now, for example, this is a rock, and this rock has, or it is rich in iron content, and this rock is placed in the environment where there is abundance of moisture or rainfall. So what happens here? The iron in the rock reacts with moisture, and this is producing oxide, and that is known as rust. And this rusting is causing disintegration of the rock. So here a chemical reaction is involved in disintegration, right? Or you can say other feature, if this is a rock and it is a limestone, it is a limestone, so this is CaCO3, calcium carbonate, and this limestone rock is in the region of rainfall. So CaCO3 reacts with H2O, the reaction will result in carbon dioxide and all, right? What is the outcome of this? It is going to dissolve in water. So limestone is dissolving in water. When limestone dissolve in water, this dissolution of limestone in water is an example of chemical weathering. Now, what you can do is take a bucket of water and take a limestone, and you just dip into that, it will get disintegrated. So this is here. Are we applying any external force on the rock? Are we hammering the rock, or is there any external pressure, temperature responsible for the disintegration? No, it gets disintegrated because of its own chemical reaction. This is known as a chemical weathering. Now, if it has to be differentiated with the physical weathering, what is physical weathering? The disintegration of the rock caused by the external conditions. External condition cause the disintegration of the rock. This will be known as a physical weathering, right? Now, some students here may argue that there is a moisture here is also external, then why we don't say it as a physical weathering and say it as chemical? If it is physical, meaning is you remove this rock and place something else, then also it should break. Remove that rock, place the third one, then also it should break. Irrespective of what is the type of rock, it is going to get disintegrated because of external condition. That will be known as a physical weathering. Then what is determining the chemical weathering? Is it the external condition or the composition of the rock? Composition. The most important determinant of the chemical weathering is the composition. Most important determinant of the chemical weathering is the composition of the rocks. Yes, are you able to differentiate between the two, chemical and physical weathering? Now, in case of physical weathering, composition doesn't matter. Whatever rock is there, if you keep in that environment, it will get disintegrated. The environmental conditions, external condition will be dominant there. Here, external condition only can facilitate. The disintegration depends on what rock is composed of, right? So here differentiate between the two. Now, so we have discussed limestone dissolves in water. This is a disintegration. Suppose this is a mountain and it has lot of limestone, abundance of limestone. It is made up of limestone rocks. This type of landforms are referred as the karst topography. Karst topography. Whenever the landform is made up of limestones, the word used is karst. Now, karst is derived from the place. This is derived from a place that is karst plateau of Tresti Peninsula of Slovenia. It is a karst plateau of Tresti, Trieste, Tresti Peninsula of Slovenia. This is near Mediterranean Sea, near the coast of Mediterranean Sea. This this karst plateau is rich in limestone. Now, based on that, all the places of the world wherever limestone is abundant, we will say it as karst. Okay. So, Tresti Peninsula of Slovenia near the coast of Mediterranean. Okay, there is a plateau made up of limestone known as a karst plateau. So, any such topography, any such landform which has high content of limestone is known as karst topography. Suppose this is a mountain that has lot of limestone in it, and this is in the region of high rainfall. So what happens here? The water percolates, water react with this limestone, the limestone dissolves. Now, when the limestone dissolves, this limestone starts moving along with water, right? Now, for example, this is rock A and this is rock B. This one is rock C. This is D. B is a limestone rock and D is also a limestone rock, and these are other rock, maybe igneous, sedimentary, depends. So if there is rainfall here, this water moves here, react with this get dissolved, this also get dissolved. What will happen to these two rocks? They will get detached. Okay, they will get detached, and all these rocks of the mountain become loose and they will suddenly fall down. This area will fall down, and this will be known as a landslide. So possibility of landslides if the karst topography is present in the rainfall region, the possibility of this disaster will increase or decrease? Increase. Okay, so note there, if the karst topographies or karst mountains, karst topographies are in the regions of high rainfall, this can trigger landslides. Example is the region of what? Region of middle Himalayas, which are having limestone rocks. This is one of the reasons why the frequency of landslide is higher in states like Uttarakhand and Himachal. Okay. Now, here don't understand that the karst is the only factor for landslide. There can be other factors like earthquakes, deforestation, cloud burst. These are also the factors for landslide. But if karst is present, this will increase the frequency of this phenomenon. Right? You can write there middle Himalayas. It increases the frequency of landslides in Himachal Pradesh and Uttarakhand. So we have learned chemical weathering. Chemical weathering is a disintegration of the rock caused by a chemical reaction occurring in the rock. Chemical weathering depends on chemical composition of the rock, more determined by the chemical composition of the rock and then external condition. Okay. Now, next is physical. Physical weathering is disintegration of the rock caused by the external factor operating on the rock, external force that is operating on the rock. Now, the most important factor that causes the physical weathering is the temperature. Most dominant factor causing the physical weathering is temperatures. In chemical weathering, the points are clear to you. Karst topographies will experience the chemical weathering, correct? Then what is anthropogenic? Anthropogenic is caused by human activity, rock disintegration caused by human activities. Here you don't get the question much on anthropogenic and biological. Whatever is there in your material, just see the example there. Rain has to be acidic rain in karst. Is there any characteristic of rainfall we are looking at? Now, you take a bucket of water, you don't take acid there, and you put the limestone. जैसे अपने गांव वगैरह में जो वॉल के लिए white wash होता है, now you don't have that narrow lack or tractor distempers or these things in our villages. So what people will do, they get these limestones and they will just put it in water and leave for some hours, and after that use it as a whitewash for the walls. Okay, they don't crush it. उसमें कोई crushing वगैरह ऐसा होता नहीं hammer से. Karst is present in Western Ghat. Western Ghats are not the karst topography. Rather, karst is a part of Vindhyas. In India, if you see karst region, it is Middle Himalayas, the Vindhyan range, Kaimur range, and also the part of Eastern Ghats and some part of Chota Nagpur plateau. Now, this we will be studying again in Indian geography. Just can take it as an information. These are the main karst regions in India. Middle Himalayas, Vindhyas, and some parts of Central Highlands also has this karst, like region of Bundelkhand is having the karst topography. Kaimur is in northeastern part of MP, right? Northeastern, you have the districts like Sindhi, Satna, Rewa. This comes under the Kaimur, extending up to Bihar, MP to Bihar. All this, see, Kaimur has the largest concentration of karst in India, and this has facilitated the location of dash industry in northeast MP. Limestone is the raw material for which industry? Limestone. Steel is there, but steel it is used in very small quantity. It is cement. Okay, it is majorly used as cement. So concentration of the cement industry in the northeastern region of MP. Right now, physical weathering is external. Factor here is temperature. Let us see the temperature conditions, how they cause the physical weathering. Now see the tropical region of a tropical desert. Tropical deserts, these are hot deserts like the desert of Sahara or the Thar desert, the Atacama desert or Kalahari, Australian deserts. So tropical desert, how is the temperature conditions during the day? The temperatures are very high, and during nights in desert there is rapid cooling of the land and the temperatures are very low. So this is known as a contrast in temperatures. Contrast in temperature. This contrast means it is high and low. Now this is happening between day and night. This is referred as the diurnal contrast. Diurnal means within 24 hours, between day and night. It is known as diurnal. Anything which is occurring within 24 hours or between day and night, we use a word diurnal. So like you have diurnal tides, diurnal temperature, diurnal rainfall in this way. So diurnal contrast in temperature is recorded in the desert. DIURNAL. DIURNAL. Diurnal contrast. Now, if there is a rock here in desert, what happens to this rock during day? The rock is heated. So let us take a condition of Sahara, the place like Al Azizia in Libya, where the temperature goes up to 60 degrees during the day. So if the rock is present there, the rock gets heated during the day and it expands. So during day, the rocks experience expansion. And the same rock rapidly cools during the night and it is going to contract. Okay, expansion and contraction alternately. So places like Sahara, where the temperatures are above 50 during day and night temperatures are like 5 degrees or 6 degrees, it is very low. So contrast in temperature, expansion of the rock during day and contraction during the night. So if this is happening multiple times, what happens to the outer layer of the rock? This becomes loose and it will fall apart. Okay, this is broken. The rock is broken and you'll have this rock and the outer layer is getting detached. Now, again after this, you'll find this layer is going to get detached. So like this, the size of the rock will go on decreasing. Okay, this is a physical weathering known as exfoliation. Foliated means layered. What is exfoliation? Layered disintegration of the rocks. Layered disintegration of the rocks. So heating of the rock during the day results in expansion, rapid cooling, contraction, alternate cooling and heating is separation of the outer layer of the rock. This process is known as exfoliation, or this is also in general referred as onion peeling process. Okay, onion peeling process. Like you have the layers in onion, right? Layers. Now you don't get into vegetables, you have cabbage also having the layers. Okay, so don't say cabbage peeling and all. So it is, main term is exfoliation. See, when the rock is breaking, it can break in two ways. One way of breakdown of the rock will be in the form of layer, and second is it may break into the pieces in different size. So this type of breakdown is exfoliation, and this is known as granular weathering. This is exfoliation weathering. So there are two types of disintegration. Exfoliation means layered disintegration, and when the rock breaks in uneven sizes and shape, this will be known as a granular weathering. Deserts are characterized by exfoliation. Okay, deserts are characterized by the exfoliation. Remaining all the places when the rock break, apart from desert, the rocks are breaking in other areas, that will be the granular weathering. Now, number two, in physical, this is the second type. First is exfoliation. Suppose we consider a latitude here, this latitude of the earth between 40 to 65 degree latitude. What are this region? These are known as temperate region. Now below 40 or below 30 it is tropical. 40 to 60, 65 is temperate, 65 above is polar. So we have three divisions here: tropical, temperate, polar. We are considering the temperate region. Temperate are also known as mid latitudes. These are mid latitude. These are low latitude, high latitude, mid latitude. So mid latitudinal region. Mid latitudinal region, or these are temperate regions. Now in this case, how are the summers? The summer temperatures are high, right? So summer temperature can reach up to 35, 40 degrees in this region. And what about winters? The winters are severe. Winters are severe means winter temperatures are very low. Summer temperatures are high, winter temperatures are very low. Means winters are severe means what? The temperatures in winters are below the, yes, below freezing point. Okay, temperatures in winters are below the freezing point, below 0 degrees. ठीक. What about rainfall in these areas? The rainfalls are moderate. These regions are characterized by, this all will be studied under climatology, moderate rainfall. Moderate rainfall, something like 160, 140, 170 centimeters per year. This is known as moderate. Moderate rainfall, hot summers, very cold winter. So is there contrast of temperature? Yes, these are also characterized by contrast in temperature, but is it a diurnal contrast? No. What is this contrast? This will be known as a seasonal contrast. So we'll say mid-latitudinal regions are characterized by a seasonal contrast in temperatures. Mid-latitudinal regions are characterized by seasonal contrast in temperature. So, do we have a seasonal contrast in equatorial region? क्या seasonal contrast equatorial region में होगा? No. Here it is hot and warm throughout the year. There is no question of much variations in temperature between summer and winter. Rather, we'll say winters are absent on equatorial region. Do we have a seasonal contrast in polar region? No. Again, it is cold throughout the year. Cold throughout the year. Summers are absent there. Winters are absent here. So these are the particular specific latitude which experience this seasonal contrast. The climatic conditions of this region is characterized by a seasonal contrast. So summers are short and hot, winters are long. Winters are long. This is clear because so as we move towards the tropical region, the length of the summer will go on increasing. So we are in middle. So you have a short summer and hot and long winters. So what will be the rate of evaporation here? Evaporation rate compared to tropical region, the rate of evaporation will be less. So you have water that gets accumulated because of rainfall, but it is not that the water is completely evaporated. Some water is left on the surface. So there is some availability of water on the surface throughout the year. Do we find that availability of water in the tropical region? Like countries like India, we get rainfall, but now you look in the month of February or March, many of the areas will become dry because everything gets evaporated. Rate of evaporation is higher than the precipitation. Then precipitation, there is very less availability of water on the surface. Here we say water availability is there because rate of evaporation is less. Reason for less rate of evaporation will be summers, which are shorter durations. Now, in such conditions, assume that this is some rock. This is a rock like this. And this rock has some unevenness. So, in this depression of the rock, there is accumulation of water. Water gets accumulated in the rock. Water remains in these gaps of the rock. There are some gaps, there are some unevenness in which the water has moved and it is present. It is present as it is. So this is in the state of water or liquid in summer. If it is winter, what will happen to this water? It will change the state and this water is going to freeze and get converted into ice. So if this water is converted into ice here, again after winter it will get converted into liquid, melting. Melting is also known as thawing. So it is freezing during winter and thawing during summers. So these regions experience alternate change in the state of water that is present in the rocks, in the gaps of the rock. So when water is changing the state, this is liquid and then it becomes solid. It becomes solid. What will happen to the volume of water? Expands. So in solid state, the water expands, and in liquid state, again it is going to contract. So there is alternate expansion and contraction of the water that is present in the rock. If this expansion continues, it expands here, what it will do? It will exert the pressure on the walls of the rock and it will widen this gap in this way. So this will become more deep. Again, this water moves down in next summer and it will contract again in winter, exert the pressure here, this will become deep. In this way, if it deepens, after some time this part of the rock will get detached or broken. Now this is known as, this type of weathering is known as freeze and thaw type of weathering, right? So this freeze and thaw, here you should remember is, did you get the concept? Freeze and thaw occurs in mid latitude and the disintegration of the rock, note down, in this case, the disintegration of the rock is due to change in state of water, with expansion and contraction, Next point, freezing and thawing, contraction of water. Next, freezing and thawing exerts pressure, on the walls of rock, causing its disintegration. Right. So all those areas, now we should understand all those areas where there is alternate expansion, contraction, or alternate availability of water in liquid and solid state. Some areas which get covered by ice, then again there is melting of ice. Such areas will experience this type of weathering. Can we find the freeze and thaw type of weathering in India? Freeze and thaw type of weathering occurs in India. Yes or no? Yes. Which region? In Himalayas. Okay, in Himalayan, lower ranges of Himalayas like middle Himalayas, which are not permanently covered with ice. They get covered with snow or ice seasonally, where there are seasonal changes. So middle Himalayas or lower Himalayan regions will experience freeze and thaw. So this is weathering. So we have discussed what is chemical and what is physical, difference between the physical and chemical weathering. Next is erosion. So Erosion involves the movement of the sediments. They require an agent. This is water, wind, glacier, and waves or sea waves. Now, suppose this is a landform and this is the agent of erosion, right? So every agent of erosion will have its source, in the sense where it begins. So the river is beginning here. So this is the source of river. River is an agent of erosion, so it has its source, and it also has a destination, means where it is finally going to reach. So it has a source and destination. So what is this agent of erosion doing at the source? Over a period, it will decrease the height of this landform. It will bring down. So what is the action of agent of erosion at the source? It will cause degradation. At the source, it is causing degradation, means it will cause a removal of the material. It will take away the material from the source, and what it will do at this region, it will deposit. Okay, so at the destination, it is going to deposit. The process of deposition is known as aggradation. So there are two processes involved in every agent of erosion. Removal process is known as degradation. Depositional process is known as aggradation. There are two processes involved. The process of removal or taking away is known as degradation. Process of deposition is aggradation. So it is creating a landform by removing. This type of landforms created at the source will be known as degradational landform. What is the type of landform created by removal? Suppose river is moving, what it is going to create? A valley. Valley is what? Degradational landform. By removing whatever is created, this will be known as degradational. And river brings here the sediment and deposits. So what is this? This is a plain, or it may deposit near the mouth, that is delta. What are these type of landforms? Known as aggradational landform. So every agent of erosion has two types of landform. One created by erosion, that is removal, other created by deposition. So there are aggradational landforms and degradational landforms. Aggradational and degradational landforms. Right? Now, so if you consider these agents of erosion, water, wind, glaciers, and wave, are these agents of erosion operating at all the places uniformly? No. So we'll say that every agent of erosion has its regional specialization, right? They are operating or they are dominating in particular region. So water dominates in the area where there is rainfall. So what are such regions known as? Rainfall regions are referred as humid regions. Where there is a possibility of rainfall, this is humid. While wind is dominant in areas where the conditions are dry, this will be known as arid regions. Glaciers are operating on what? Mountain tops, or this will be in polar region. polar region, glacier at the poles. And what about waves? Waves will operate at the coast. So waves also can erode, waves can deposit, right? If the wave is depositing, it will create a large area of sand near the coast that will be known as beaches. Okay. If the wave is eroding, it will cut the coast and create some vertical structure. This type of features are known as cliff, CLIFF. So every agent of erosion operate in certain region, they will develop some landform. So a landform created by water, this will be known as, this type of landform, fluvial. Landform created by water is fluvial. Example of the fluvial landform is valleys, plains, delta, in this way. Wind is creating the landform. This is known as Aeolian landforms created by the winds. Example, desert, you have a sand dunes. There are many more, we'll discuss in detail, but time being you just take the known examples. Aeolian, AEOLIAN, or simply in some books it is EOLIAN. Aeolian landforms created by wind. Glacier, this is simply referred as glacial landform. Example for this is like depressions known as moraines. We are not going in detail at this stage, just remember few. Waves, these are coastal landform like beaches, shoals, cliff. Right. So in this way, now you should tell me, are these two processes of weathering and erosion dependent on each other? Weathering and erosion, or they are independent of each other? They are dependent on each other. If weathering is there, it will increase the intensity of erosion. Weathering is there, it will increase the intensity of erosion. And can erosion increase the intensity of weathering? Is it possible that erosion is increasing the intensity of weathering? Or you understand in this way, weathering is determining the erosion, weathering helps in erosion, and erosion will also help in weathering. Now take example, suppose this is a river and there is a rock here. Now this rock at this place, it is broken and it is broken into two parts. Now it is moving. Okay? It means that weathering has facilitated the process of erosion. Suppose the weathering has not occurred, but the intensity of the river has increased, which has caused this rock to move and fall from one level of the river to other, and when it is falling down, it got broken, right? So it has a friction with the surface and then gets disintegrated. So this is the effect of erosion on weathering. So weathering and erosion are the interdependent processes. Weathering and erosion are interdependent processes. Right. So this is about the exogenetic force. Now when we are considering a denudation, this is denudation, and the height of the landform is decreasing, then decreasing, and then finally brought down. Which of this process, weathering and erosion, is more effective in reducing the height of the landform? Weathering or erosion? More effective in decreasing the height of the landform. Huh? How many for weathering? And only erosion? Both weathering and erosion? There are repeated hands. So suppose you take in this way, this is a rock, right? This is broken here. This is weathering, but lies as it is. Will the height of the landform get reduced? No. The height will only reduce when the material is taken away. So which is more dominant? Erosion. Erosion controls the degradation of the landform. If the material is or the rock is disintegrated and material is left as it is, the topography appears to be same. The relief appears to be same. So if you want that the landform is degraded, you have to remove the material from that place, and that is possible by erosion. Therefore, this end product what we are getting out of operation of denudation will be referred as the erosion surface. It is not known as weathering surface. It is known as erosion surface, which is created by removal of the material. So what is the definition of erosion surface? It is the end product of, note down, end product of the geomorphic process, end product of the geomorphic process. Geomorphic process means denudational process, which lies close to the base level, lying close to the base level. Now in all these we have learned the material, even if it is lying in this way and becoming loose, will move down, is transported. If let us say there is no water, wind, glacier, still the material which is present at such elevation along the slope can move down. Then what is the agent of erosion? Gravity. Okay, so gravity also can be considered as a universal agent of erosion, which is acting at all the places. Gravity is the universal agent of erosion, where the material, irrespective of whether other agents are present or not, other physical agents are present or not, the material moves under the influence of gravity along the slopes. So this is about the exogenetic forces. Now we have to discuss in detail about the agent of erosion and landforms created by the agent of erosion. So we will start with the alluvial, then glacial, karst. In this way, one agent we will cover, but I'll be requiring this may take some time to cover this. So what we can do is we can take up one topic that is our regular topic. We'll start with earthquake, and end of the class half an hour we'll take one agent of erosion. In this way 4 classes we will be able to finish 4 agents of erosion without disturbing the regular topics, right? So that pattern we will follow. Otherwise, if I cover only alluvial and fluvial, or fluvial and glacial one day, so 2 classes will go in this. We don't have that much time. Okay. I hope this is clear now. This is endogenetic and exogenetic forces. There will be some factual information related to this topic. Please refer the NCERT class 11th. Hmm. Hmm. Endogenetic has stopped in Aravallis. It is in case of Himalayas. Okay, Himalayas, the endogenetic is active. That is why the height of the Himalaya, in spite of denudation, is not decreasing. Rather, the height of Himalaya is increasing. But where is Aravallis? When Aravallis was formed, they were formed by the collision of the plates that were there 2.5 billion years. Today, Aravallis are not located at the plate boundary. That has to be related with plate tectonics. Not all the places will have endogenetic forces. Yes, this part is clear to everyone. Are we having endogenetic force now operating here? There will be only few events of endogenetic forces, and that too depends on the boundaries of the two plates. Okay? Yeah. How? Rock, we don't say fault is depending on this, but the formation of the fault, suppose this was the two block A and B, and this was initial layering like this. Okay? And if this block B has moved down, what will happen here? This layer is remaining here, and the block B, this layer will be shifted down in this one. So this is the mismatch between the two rocks, and that will help in understanding whether it is a reverse fault or normal fault. So fault are gauged based on the arrangement of the rocks. Fine. Why is a rift not formed in the fault? Faults are the initial stage. If the tensional force continues, there will be rifting. Explain the syllabus of geography. I think that is there in first class. We have covered. Get into online students will have access to the recording. You can watch again. Okay, we'll continue next class. Thank you.